Good morning, students. Today we are going to start a new chapter, Motion in a Straight Line. Mechanics is the branch of physics deals with the study of motion or rest. When we look around our surroundings, we can see that different objects are in motion, different objects are at rest, etc. Now, listen here. I am standing here and taking the class. Am I at rest or in motion? There are slight movements of my hands, but you can say that I am at rest. Now, similarly, now you are sitting in your room and you are viewing me. You are listening to my class. Are you at rest or in motion? I can say you are at rest with respect to your room, with respect to the surroundings. Okay. Now, if a person is looking, a person standing on the surface of the moon and looking both of us, he will find both of us are moving. That means when you are sitting in your room and listening to my class, since the earth is revolving around the sun and the earth is rotating about its own axis, to a person standing on the surface of the moon, we both will appear moving along with the earth. Okay, so according to both of us, we are at rest, but according to a person standing on the surface of the moon, we both are in motion. So we can say motion and rest, both of them are not absolute, they are relative. So this chapter mainly deals with the motion and rest of the object in a straight line. So as I told, mechanics is the branch of physics which deals with the study of rest or motion. Mechanics is divided into three parts: statics, kinematics, dynamics. Statics means it is the branch of physics which deals with the study of objects at rest. Study of objects at rest, that is statics. Now what is kinematics? Kinematics means it is the branch of physics deals with the study of objects in motion without taking into consideration the factors that cause the motion. Meaning, a car is at rest. After some time, the speed of the car is 40 km per hour. In 5 seconds, find the acceleration. In this question, I told initial velocity is 0, final velocity is 40, time taken is 5 seconds, find the acceleration. This is what I told you. I didn't tell the cause of the motion of the car. What is the cause of motion? Some force should come, no? For that, engine should work and engine should provide a force. That mechanical force helps the car to move in a straight line. But I am not discussing about the cause of its motion. I am just telling the car moved. That branch is kinematics. Now the third thing is dynamics. Dynamics means the study of the objects in motion taking into consideration the factors that dealt with motion. So that is all about dynamics. So only in dynamics we will be studying about the factors which affects motion. That means the force. Force is the one which causes motion, or the mechanical power expended by the engine. So all those things will be considered only in dynamics. Okay. Now let us see what is rest, what is motion. Object can be say at rest if it does not change its position with respect to surrounding or with respect to time. So the object is at rest if it does not change its position with respect to time or with respect to surroundings. Now, when can we say that the object is in motion? If the object changes its position with respect to time or surrounding, we will say that the object in motion. And as I told you, motion and rest are relative. There is no absolute rest, there is no absolute motion. For example, imagine two persons are sitting inside a car and the car is moving along the road. According to both the persons, they both are at rest because they are sitting inside the car and they are talking each other. According to both of them, they are not moving. But imagine a person standing on the road and looking at them. According to that person standing on the road, these two persons are moving in the car. Understood? So with respect to the car, they are at rest. But with respect to the person who is standing on the ground, they are in motion. That is why we say absolute rest and absolute motion is not there. Motion and rest are always relative. Now let us see the consideration of point object. Is there any object called point object in the universe? Absolutely not. If I take atoms, if I take molecules, nucleus, everything is having a size. So there is nothing called point object. But we have to consider the point object when we deal with the motion. So what is actually a point object consideration? If the distance traveled by the object is very much greater than the size of the object, then we call that object as point object. See, for example, I am coming to school by car. The length of the car is almost 4 meters long. 4 meters. And the distance from my home to school is around 40 kilometers. So comparing to the distance travelled by me, the size of the car, which is 4 meter, is almost negligible. So I can consider that car as a point object. So when principal calls me from school, I'll tell that, Father, I'll reach now within 5 minutes. And when I reach here, when I reach school, I will say that, Father, I have reached. I will not say that, Father, my car's front bumper has reached the school now. Back bumper will reach after some time. Will I say it like that? No. No. I'll say, Father, I have reached here. So I consider car as point object. Okay? But if the distance covered is very much lesser, say for example, the car has travelled 2 meter and the length of the car is 4 meter, then we cannot consider car as a point object. Okay? Yes. Now, types of motion. Motion can be categorized into 3 types: one-dimensional motion, two-dimensional motion, and three-dimensional motion. One-dimensional motion means only one coordinate axis is changing. See, we have already learned about Cartesian coordinate planes. I will show you. You can draw like this. This is x-axis, this is y-axis, this is z-axis. Even though I am drawing z-axis like this, actually the z-axis is towards you, like this. Z-axis is in space. So x, y and z-axis. This is actually called Cartesian coordinates. Cartesian coordinates. If any body moves in such a way that only one axis is changing, say for example, a car is moving along a straight line, only x-axis is changing, then this motion is considered as one dimension. Now imagine another situation. A rocket is launching like this. Only y-axis is changing. Okay. So such kind of motion is called one-dimensional motion. If only one axis changes with time, then we call the motion as one-dimensional motion. Now let us move on to two-dimension. Two-dimensional motion means both x-axis and y-axis changes. Any two axis, it may not be x-axis and y-axis always, it can be x-axis or z-axis or y-axis and z-axis. Any two coordinate axis changes with time. Then we can say that the motion is two-dimensional. Example, planets revolving around the sun. It is moving in a plane. So motion in a plane is an example for two dimension. Boat is moving along the river. River is having a flow. So boat can't move in a straight line like this. Boat will go and boat will just turn and reach the other end. So that turning will be there. That means it is motion in a plane. Motion in a plane is two dimension. And the third one, all the three coordinate axis changes with time. That means a butterfly moving in space. Have you ever seen a butterfly flying in a straight line? Butterfly cannot fly in a straight line. It will move only in a zigzag manner, achieving all the coordinate systems in space. So butterfly moving in a space is a best example for three-dimensional motion. Or you can say the kite moving on a windy day. That is also an example for three-dimensional motion. So for one-dimensional motion, I can say motion in a straight line, example freely falling body. Two-dimensional motion, I can say motion in a plane, planets around the sun. And the third case, I can say three-dimensional motion, the motion in space, example kite on a windy day. Okay, that's all for today. Bye.